All right, guys, morning. Let us get into this a couple minutes late already. So let us go straight into it. So this was one of the papers I gave yesterday. Nice paper. Pass mark is 80%. 80%. And you have until the rest of the week to attain that 80% before we get to Saturday next week where the pass mark will move again. All right. You have to have continuous progress. All right. So this was the January 2024 exam paper, very recent exam. So expect your exam to be of this level. All right. Any question you got wrong, you need to go and redo it. All right. I'm wondering if I should start at the front or start at the back. I'm just gonna start at the front. First question says, express this as a simple fraction. As a fraction in simplest form. So we can basically put this in the calculator and see what we're getting. All right. We can put that in the calculator, see what they get, because you are free to use your calculator. So it's 1 minus a bracket 1/30 plus 4/5 over 15, sorry. 4/15. Close that bracket. That's 0.77/10. Right? Make sure you put in the correct thing. That fraction is 7/10 right here. So this is equal to 7/10. Simple as that. Next question. It says a 2-story car park has a total of 1,020 parking space. At 6:30 hours, at 6 a.m., 6:30 a.m. in the morning, one morning, 1/30th of the 1,020 space is filled. So we have 1/30th of this is filled one morning. All right. Then it says during the next hour, no car left the car park, but an additional 415 of the 1,020 space was filled. So they are adding 415 to the 130 that they have so far. All right. It says determine the number of parking spaces that are not filled at 7:30. Now these numbers relate to the calculation that we just did up here now. Actually, you know. So it's like you have 1/30th of the total, and then you added another 415 to the total, right? And so the amount that is left is the total minus this fraction. So this is the same fraction that comes out to, you know. So the one represents the whole. Yeah, so in fraction form, right, the amount that is left is a whole minus the fraction that is filled. So 1/30th was filled for one, it had 1/30th first, they added 415. So the total amount in terms of a fraction that is filled is this. So the space that is left as a fraction is 1 minus that, which is this. So the answer down here is actually 7/10. So you have already worked out the fraction that is left, 7/10. So if you make that recognition, this question will come very easy. The answer down here is just 7/10 times the 10/20. All right? 7/10 times the 20. And I hope you were able to pick up that it's the same fractions that were in that question up there. Right? That is it. So it's a very easy question. So work that out, and that's why it was only 1 mark for it. See? Only 1 mark for it. So CSEC kind of evil in a sense that they did not specify the connection. You have to basically see. Right? You have to see for yourself. But that is what it is. The amount that is left is 7/10 of the 10/20. That is why the question was only valid 1 mark. So it is 7/10 or 0.7 times. It's 7/10, which is 0.7 times 10/20. And 740 is left unfilled. But go to that, simple as that. 1 mark. So it could be that they expected to work out all of those things for 1 mark. All right. The question says, of the 10-20 parking space, 20% are at the top level. 20% are at the top level. How many parking spaces are at the top level? 20% of them, right? Simple again, another 1 mark question. So it's 20% times 10-20 equals. So 20% of that, 20% times 10-20, 204. 204 is the answer. 20%. Next question. It says, some of the spaces are reserved for monthly paying customers. The ratio of the reserved space to the non-reserved space is 5 to 7. 5 to 7. So the total space now is broken down in the ratio 5 to 7. 5 to 7 ratio add up to 12. Right? So what that means, we have the let's see it again. Some of the spaces are for monthly paying customers. The ratio of the space for non-reserved, let's go again. So the reserved to non-reserved. So reserved to non-reserved is 5 to 7. 5 to 7. For a total portion of 12. Total portion of 12. 5 and 7 is 12. All right? And it says, calculate the number for non-reserved. Non-reserved. So the non-reserved would be that portion out of the 12 times the total of 1,020. But I can understand that. 7 out of 12. So the ratio is 5 to 7 for total parts of 12. And I want to know the non-reserved portion, which is the 7 part of the ratio. So the 7 portion of the ratio is 7 out of 12, and the total parts is 12. 7 out of the 12 times the 10, 20, and by 1,020 parking spots. So it becomes 7 out of the 12 parts times 10, 20. That's what you're working on. That's the number of non-reserved parking space. But that's on that. But that's on that. All right. So that becomes 7 out of 12 times 1020. That's 595. 595. And what we could have done is we could have multiplied this now, this ratio by a number to make the total side reach 1020. And I've gotten just the same. Right? But this is even answer not, that's how ratio goes. So the ratio is 5 to 12, 5 to 7. Total parts in the ratio is 12. And the portion of the non-reserved, therefore, is 7 out of the 12 times the 1020. Right? 7 out of the 12. A ratio is like a fraction, really, a fraction of the total. That's what a ratio is really, like a fraction of the total. So 7 out of the 12 times the 1020 total parking space. Down here now, it says the cost for parking at the car park is shown in the table below. So under 30 minutes, it is free. Between 30 minutes and 2 hours, it's $2.25. Between 2 hours and 4 hours is $5.50. Between 4 hours and 8 hours is $9.25. Between 8 hours and 24 hours is $15. And a 1 week ticket is for $40. So you can park for the whole week for $40. Let's see what is happening here. It says, Michaela leaves the car park at 18:30 hours and she pays $9.25. So she pays this amount, $9.25. So it means that she was in there for between 4 and 8 hours. She paid $9.25. Right? And she left at 18:30, that's 6:30 in the evening. determine the earliest time she could have arrived there. So the earliest time she could have arrived there is the time that would have allowed her to spend the maximum time possible, which is 8 hours. So she would have arrived there 8 hours before 1830. That's the earliest time she could have arrived there. So that's 1830 hours minus the maximum time she could have spent, which is 8 hours. Which means that she would have arrived there at 10:30 hours. 10:30 hours is the answer. But understand that? Because she paid $9.25. Means that the maximum time she could have spent there is 8 hours. So the earliest time she could have reached, if she leave at 18:30, you have to subtract the 8 hours from the 18:30 hours. All right? 18:30 hours is 6:30 in the evening. So she could have got here from 10:30 in the morning, spent 8, and then spent 8 hours. That is the answer right here. Next part, sir. It says, Dan Raj, what some names are given here. Dan Raj bought a weekly parking ticket for $40. Yes, they said a weekly ticket is for $40 right here. All right? He bought a weekly ticket for $40. That week, he visited the car park on 5 different times. 5 different times. It's the length of time he parked on each occasion is given below. So he parked this amount of time. Those are the 5 times that he parked. All right? It says, show that Dan Raj saved $8.50 by buying the weekly ticket. So what we need to do is work out what the total amount he would have to pay if he parked these actual times and paid for parking those actual times. No, don't pray. I'm gonna work it out. All right? So we'd have to go now and work out the total time that he would have spent, the total money he would have spent if he paid to park each time and see what the difference is. What the difference is to the $40. And that's how we're gonna get the 850. So it has to be that if you would have spent a total of $40.50. We have to show the work. Right? So let's work it out. So if you worked to park 25 minutes, that would be free, right? Anything under 30 minutes is thing. So you would have spent $0 here, so. Let's work them out. You would have spent $0 here, so. For 7.5 hours, 7.5 hours, you would have spent this, right? Because you're within that range. 9.25. So you would have spent 9.25 here, so $9.25. For 11 hours, 11 hours, you would have been in this range. You would have spent $15 there, $15 here. And for 8.75 hours, another $15 that you're going to pass this. Right? So you would have had to spend this again, another $15. I'm going to pass 8 hours. Once you go 8 hours, you're spending $15. And then for exactly 8 hours, you would have spent $9.25. So between up to 8 hours. This is if you spend more than 8 hours. So if you spend up to 8 hours, you spend $9.25. So you spend $9.25 years ago. $9.25. All right? And this total is what? This total, they don't give a lot of space to work, but that total would have been total if he was doing if he was parking, if he was paying each time, would be basically $30, 2 times 30 plus 2 times 9.25. Right? 2 times 15 plus 2 times. So 2 times 15 is 30 plus 2 times 9.25. Okay, let me stay there. So 2 times. So you'll have spent $48.50. That would have been $48.50 if he was parking each time. Therefore, the amount saved by paying $40 for the week is equal to $48.50 minus the $40, which is the $8.50. And that's what we have shown. All right, so that is it. So what I did, I put the time that the dollar, the amount that you would have to spend up here if he was parking, if he was paying each time. All right, that is $8.50 is paid. He's saving by just paying $40 for the week. All right, that finishes that question. Number two. Number two wants us to simplify this. So I guess we have to factorize the numerator and the denominator and simplify it. So numerator, a common factor of x first. You factor the x on the numerator, and then you're gonna get x plus 7 inside the bracket after you factor the x out here, divided by, factor this now, that's the difference of two squares. Right? That's x squared minus 49. Let's write it over here. X squared minus 49 is the same as x squared minus 7 squared. The same as x minus 7 times x plus 7. That's what that is. So I'm going to put this factor under here. So it's going to become x minus 7 times x plus 7. Now what happens now is that this x plus 7 cancels with this x plus 7. And I'm left with x over x minus 7 as the answer. So that simplifies to x over x minus 7. That's the answer right here. Simplify. Very good. Next one. It says, find the value of r if this times is equal to that. What do we know? When you multiply indices with the same base, you add the power. So x squared times x to the 6th power is actually equal to x to the 2 plus 6, which is x to the 8th power. So it means that this r is equal to 8. But I can say that. So therefore, the r is equal to 8. R is equal to 8. That's the answer right there. All right. When you multiply indices, the same base, you add the powers. You're dividing, you subtract the powers. Right? Next one. Find S when S cubed is equal to 8. Must know that that is 2. 2 cubed is 8. You don't know, you put cube root both sides. So if you have S cubed equals 8, then you put cube root both sides to get rid of this cube. Cube root. Cube root this side and cube root this side. The cube root cancels away that cube. And so you get S equals the cube root of 8. If you can get the cube root of 8, you're going to get 2. 2. So the S is 2. Right? 2 cube is 8. So the S equals 2. Nice easy questions, these are very easy questions. Let's continue down here. It said the diagram below shows a triangle and a quadrilateral. So that's a triangle, that's a quadrilateral. It says all angles are in degrees and are written in terms of A and or B. It says find for the triangle, show this equation is true for the triangle. So for the triangle, we know that the sum of these three angles is 180 degrees, don't it? 180 degrees. 180 degrees is the total angle here. That's what we're going to use. And for the quadrilateral, see, for the quadrilateral, show that one. For the quadrilateral, the total angle in a quadrilateral is 360 degrees. That's what we know. So for the triangle, the sum of these angles is 180 degrees. So we can set up that equation. So this angle first, which is A plus B, A plus 2B, sorry, plus this 3B, plus this A plus 9 is all equal to 180 degrees. Or 180, because the angles are in degrees, so we don't need to put on the degree. You consolidate the value. This is A and A, that's 2A. Then the B is now. This is B and B, that's 5B. Then this 9 goes over here and subtract and becomes 180 minus 9, which becomes a 171. So you get what they said. This gives us 2A plus 5B equals to 171. That is shown. I guess we're going to do something similar for the quadrilateral. So for the quadrilateral now, again, the total angles up here is 360. So we can do a similar thing with just 4 angles we're doing now. So let's do this one first. 3A plus 2B. 3A plus 2B plus this 6A plus this is 18 plus 3B plus 18 plus 3B plus this one, 3B minus 2A plus 3B minus 2A. That's all equal to 360 degrees. And you simplify and consolidate. So look at the A values is 3A and 6A, that's 9 minus 2, that's 7A. 9 minus 2 is 7, so you have 7A. So look at the B's now. That's 2B and 3B make 5B, and another 3B right here, so make 8B. So the B's add up to 8 B's plus 8B. And that will be equal to 360. And you take this 18 and carry it over here and subtract it. That's the only number in there, that 18. So you subtract the 18. Subtract the 18. When you subtract the 18, you're going to get the 342. So this now becomes 7A plus 8B equals 342. And that again is shown. Nice and easy. Then it says, solve the pair of simultaneous equations in part 1 and 2 to find the value of A and B. Show all working. So we're solving these two equations now simultaneously. All right, so simultaneous equations now. So it's 2A plus 5B equals 171, and 7A plus 8B equals 342. So you can use as well, you can use a substitution method or elimination method. I prefer to use an elimination method, right? So you can choose to either eliminate the B values by making it adjusting two equations to make them become equal. So you can subtract them to eliminate the B, or you can multiply by a value to make the A values equal. And so you find the B values first. Let's say we're going to find the A values first. We're going to eliminate the B. So look what we're going to do now to eliminate the B. We multiply them by a factor to make the two of them have the same size. We want the B's to have the same size. So the lowest common factor of the 8 and the 5 is what? 40, right? 40. If we're doing this one, would I use what? 14, right? If we're eliminating the 8, would I use 14? So we'll do multiply this one by 8. I'm going to multiply this one by 5. So that two B values become the same. I'm going to find the A values first. All right? So multiply that equation by 8. So multiply all of those values by 8. So the 2 times 8, the 8 times 2A is clearly 16A. The 8 times 5B is 40B. We want 8 times that now. 8 times 171. 8 times 171. I'm going to get 1368. Then this equation now, multiply this one by 5, so we can get the B value to be the same. So it's 5 times 7 is 35. That's 35A. Plus, multiply this by the 5, we're going to get 40B. Equal. Multiply this by the 5 now, so what we get? That is 342 times 5. That becomes 1710. 1710. All right? Then now to eliminate that 40B, you subtract the two equations because they have the same sign. Subtract the two equations. So we're going to subtract. Subtract. Let's look at it. Subtract. Because this is the bigger value, let's subtract it this way. So I want to use the bottom one minus the top one. So 35A minus 16A. So you subtract the values on this side first. 35 minus 16 is how much? That's 19A. So 19A. When you subtract, you get 19A. Then these are eliminated. The 40B minus 40B to be gone. Equals, that would be 1710 minus 1364, 1368. 1710 minus 1368. That gives us 342. Then to get the A, gonna divide by the 19. So the A gonna be 342 over 19 equals. So it's 342 over 19. That gives us 38. So the A equals 38. Now that you know the A equals 38, you're gonna substitute the A now back into one of these two equations in order to find the B. Let's also substitute it in this one. So we can just say, and from this equation, we're going to substitute the A in there. So it's going to become 2 times 38 plus 5B is now equal to 171. All right? Don't give a lot of space to work, but that's how it is. So we're going to subtract this over here and then divide the 5. Look at it carefully. We're going to take this 2 times 38, subtract it over here, and then we divide the 5 on that. So we can get one expression for the B. Yes?
Sir, sir, it's 18, not 38.
18? All right, my
Yes,
mistake.
sir.
I divided my character by 9. My mistake. I put 9 on the calculator. See there? My mistake. So I divide by 9. It should have been 8. It should have been 19, right? 19. All right, thanks for that. So it's 18 is the answer. All right, 18. All right, so this is 18. All right, good. So then the B then is going to be 171. Subtract the 2 times 18 over here, which is actually 36. We can still put 2 times 18 there. Then take the 5 and divide under it. Divide it by 5. And then work that out. All right, so we can just do that calculation quick. It becomes a fraction of 171 over 171 minus 2 times 18 and dividing that by 5. And that becomes 27. So those are your answers. A equals 18 and B equals 27. All right. Thanks for the correction. Huh? Yeah, my first another way, that's fine. That's why I know I get to it. Many ways. Could I use a substitution method? Could have eliminated the A first? It don't really matter. That's it. But you want to eliminate A first. You made the 2 A values the same. Right? So that in your way, you find the B values first. Find the B value first. That's fine. Right? That's okay. All right, that finishes that question. Come. Number 3 is a construction question. So let me see if I can bring up the let me see if I can bring up the construction thing. Where is it? Where is it? Wait, oh, right here. All right, so let's see what I want to construct. So I always say sketch it before you construct. Sketch it first, and then construct it, right? So this says in triangle ABC, AC is 8 and BC is 5. Using a ruler compass, using a ruler and a compass on the construct triangle ABC. Oh, they want us to construct it on this line. So they actually give us that line first to begin with. And they don't tell us the length of that. So we just have a construct. All right. So what it means, from here, we need to construct AC 8 centimeters. I will draw an arc that is 8 centimeters from here, so. And then from here, BC is 5 centimeters. I will draw an arc that is 5 centimeters from here, so. And then where they meet is the point. So let's do it over on the thing over here still. And then we can scale it up. But I don't know the length of this line, so we're just going to show you what the construction will be, because I don't know the length of this line. I don't know the length of this line. So I'm just gonna draw a line and do what you would have to do. So if you start with this line, let's say that is the line that I gave you. And you want to construct. And this is the A down here. And this is the B. And what I say is that the AC must be 8 centimeters. It means that you have to use a compass and open it up to 8 centimeters. Lock it. On this end, I'm going to make an arc that is 8 centimeters. Let's make it in red. So up here, you're going to make an arc that is 8 centimeters up here. Then from over this end, you need an arc. Oh, man. Sure. Let's make it again. 8 centimeters. So everywhere on that line is 8 centimeters from here, right? Still not cooperating. Then from the other end, we need to make an arc that is 5 centimeters. So we're going to measure 5 centimeters again with the ruler. So you come to one end. You're going to open it up 5 centimeters. And then you lock it. Move the ruler. And you come to the other end. And you're going to come around here. And you're going to cross that one. And that is it. It means that is where C is. So when you join A to this intersection, wrong line. So press undo, but mess me up again. So, all right, let's go again. More mass equals better mass. I still have the 5 centimeters. That's 5 centimeters still. 5 centimeters. So let me make the arc again. Make it in red. Oh, it's in red. Device the merit a bit of problem there. All right, and from this end, I want 8 centimeters. So I've got to measure the 8 centimeters again with the ruler. So I measure the 8 centimeters again. Lock it, move the ruler, and from this end, I'm gonna make an arc up here, cross that one. All right, into this. When you draw a straight line from this end through to that intersection, straighten it. And you draw one from here through to the intersection, and that is a triangle. Means that C is right here. This is 5 centimeters. This is 8 centimeters. All right? It's a measure and state the value of angle BAC. Now, I don't know what it is, because I don't have the actual paper. You can tell me if it did those correct things, what you got. Right? But I don't know what it is. So you would have to measure this angle down here. So the angle at A. The angle at A. So let me show you how it measure the angle at A now. So you in a protractor, one angle down at this point, A, put the eye on the point, and then you rotate until the zero pass through zero, the baseline pass through zero. And the zero is the inner scale. And that looks like 38 degrees on this paper. This diagram is 38 degrees. I don't know what it is on the earth because I don't know what the length of AB is. But on this, it will be 38 degrees. You measure on the inner scale, 38 degrees. But I don't know what it is. What did I do? What did I do? Okay. Right. So imagine 38 degrees. So let me copy this over onto the screen. I don't know what it is. I'm gonna copy this and put it on the screen. Come on. I don't know what it is. I don't know because I would have to do it myself. But I don't know what the actual you have to have the actual paper in the exam to know what the correct number is. You get me I say? Right? We don't know. Because that line can be any length. We don't know what the actual length is. So you have to have the actual paper to do. I'm just showing what the process would have to be. All right? So let me copy this. I'll paste it over here. So basically that's how we're supposed to get. Then after you do that, you measure. So what it is that this arc is an 8 centimeter arc. And this one is a 5 centimeter arc. No, lie. Other way around. This one is the 8 centimeter arc. So this one is the 8 centimeter arc. This one, 8 centimeter arc. And it's drawn from A. And this one is a 5 centimeter arc. And it's drawn from B. This one is from A. And you're going to measure this angle. Measure this angle. And record what it is. Right? That is it. But I don't know what the actual length of AB is. But that's how your construction would have to be. I'm not showing you that. Next question. And put down what I get down here. I don't know what it is. All right. That finishes that. Next part. The next part says the diagram below shows a quadrilateral, shows an equilateral triangle. So the three sides equal. So the three sides equal, the three angles equal 60 degrees. You know that, right? An equilateral triangle. So this angle is 60 degrees. This angle is 60 degrees. And this angle up here is 60 degrees. And then if this line is perpendicular bisect at the base, there's also bisect this angle and this angle. So each of them is now 30 degrees. 30 degrees. All right. So the base is 13 centimeters. So the full length across here is 13 centimeters. And the height is 8. It says calculate the height each. So the base is 13 and the equilateral means that all the sides are 30. But I can say that. All the sides are 30. So this side are 13 centimeters though. And it's a 13 centimeters though. But this divided, okay, what we can do is divide it into a divide and put a right angle triangle on it like this. In that right angle triangle, we're now trying to find the height h. Trying to find this height h. And this length is going to be 13 over 2 centimeters. That's half of the base. Why understand that? 13 over 2 centimeters. I could put 6.5. Right? And to find the h, I'm going to work in this triangle is Pythagoras steering. That's one way to do it. You could also use tricks by putting this angle down here at 60 degrees. I could say sine of 60 degrees equals opposite over hypotenuse, or cos of 60 degrees equals adjacent over hypotenuse. Well, it's the opposite of one, so we can do that. So we can use tan equal opposite over adjacent, or we can use sine equal opposite over hypotenuse. Your choice, right? So whichever way you want to use, you're going to get the same answer. So if it's in Pythagoras' theorem, it's going to be that the hypotenuse squared is equal to 8 squared plus the 13 over 2 squared. I'm trying to find this. So take this away and subtract it. You're gonna get the 8 squared equals 13 squared minus 13 over 2 squared. And then to find the 8, you can cut off the square and square root instead. So you can cut off the square and square root this side instead. Do that calculation, that will give us the h equals. And if we do the calculation over here, here's my calculator. Let's do this. Let's do this. For this calculation, it's going to be square root of 13 squared minus bracket. We could just put 6.5. But 13 over 2 is 6.5, right? 6.5 squared. I'm getting 11.25, which is 11.3 centimeters. Or we have done it another way. I use tricks. We have used tricks as well. So in that triangle, we could have said sine of 60 degrees. Sine of this 60 degrees. Sine of 60 degrees equal the opposite side of our, which is h, over the hypotenuse, which is 13. So to find the h, we'll take the 13 and multiply it up here. So the h will be equal to 13 times the sine of 60 degrees. Therefore, the h will be the same thing, I'm sure. Let's do it. 13 times the sine of 60 degrees. 13 times the sine of 60 degrees. See? 11.2 something exactly. Same thing. 11.3 same. 11.3 centimeters. And there are yet other ways you could have done. There are still other ways you could have been done. All right. So, but I think getting that right on the triangle is the easiest way to do it. So this is our method. Or. Next question. In exam, we're going to do it one way, but I do it 2 ways. Let's do it one way. You want to check your answer another way. It could be quick and check your answer another way if you have time. All right. Next question. This is no transformation. Don't need this and put this all over here. This question said the diagram below shows 3 triangles P, Q, and R. It says triangle Q and R are the images of P. So this is the original one. No, sorry. This is the original one. So this is transformed to that and then transformed to that, right? That's what it says. So Q and R are the images of triangle P after undergoing a double transformation. So that double transformation. So I get P, Q. P go to Q first and then to R. Let's see what it says. So we're going in alphabetical order. So after going a double transformation, it says describe fully the single transformation that maps P to R. So it's P to R first. We're doing going alphabetical order. So this to this first. This to this. So if you observe these two, this one and this one, see that they shape exactly the same, just in a different position. So that's a translation. Translation. And the translation you need is how many units to the right and how many units up it went. And you just need to see what happened to 1 point. You can use this point, for example. So this point moved to here. And you count the units on this. Make sure that one box is 1 unit. Horizontal, that is true, boy. You know, some I run out of my class. Every day I talk about the same thing. We talk about talking, I tell you don't come back. And then now vertical is the same thing. All right? Vertical is the same thing. One box is 1 unit. So you count the boxes across. That's 2 units this way. And you count the boxes up to here. What is that? 1, 2, 3, 4 units up. That's 4 units up. So the translation is 2, 4. See that? 2 units to the right, 4 units up. Just need to see what happened to 1 point. So P map to R, transformation P to R is a translation. Translation. 2 units to the right. And 4 units upwards. I can say given by 2, 4. This represents the translation as well. 2, 4. That's 2 units to the right, 2 units upwards. Then you want to know you go from R to Q now. R to Q. So from R to Q, this one to this one. Clearly, that's a reflection because the orientation is reversed. You can just kind of test it if you're not sure. Right? So this point corresponds to this point. Let's call them A. This point corresponds to this point. Let's call it B. This point and this point corresponds. Let's call them C. We check the orientation on this one. A, B, C is that way. On this one, A, B, C is that way. So the orientation has been reversed, anti-clockwise to clockwise. And once the orientation is reversed, you have a reflection in a line. A lot of the times, we confuse reflection with rotation. To make the distinction, we can just check the orientation. If the orientation is reversed, means that is a reflection in a line we have. Reflection in a line, the only transformation that reverses the orientation. But orientation is how the letters go around the object in alphabetical order. Right? So that is it. So by so doing, we know that the orientation has been reversed, and so we have a reflection in a line. Now that we know the reflection in a line, we need to know what the mirror line is. The mirror line is halfway between corresponding points. So halfway between these 2 points. 1, 2, 3, 4. So halfway is 2 units between them. So the mirror line looks like it is here. That's the mirror line. Same thing. Halfway between these 2. And these 2 is 3 and 3. So that is our mirror line right here. That mirror line is the line, a vertical line passing through 1. So it is x equals 1. So reflection in the line x equals 1. Right? A reflection in the line x equals 1. When you're describing a reflection, you just state the mirror line as an equation or state the physical line at the x-axis or the y-axis. So this one is a reflection in the line x equals 1. Done. That's what it is. A reflection in the line x equals 1. Simple as that. Nice and easy, guys. Nice and easy. Let's go. Next question. Number 4, functions. It says consider functions f and g, f and h, sorry, f and h. First I want f of 4. We're going to put 4 in the f function right here for f of 4. Easy. That becomes 2 minus 5 times 4. 5 times 4 is 20. 2 minus 20 is negative 18. Negative 18 is that answer. Hey, touching flip. Touching flip. Negative 18 is the answer. Next one, h of 0, we're going to put 0 in the h function up here, so the x is. All right? Remember the h is 5 to the 0. So put 0 in there now. So that becomes 5 to the 0. Any number raised to the power 0 is 1. So that equals to 1. Done. Next one. f of h of negative 2. So the f of h of negative 2, we're going to do f of negative 2 first. H of negative 2 first. Remember now that the h of x is 5 to the x, and the f of x again, f of x is 2 minus 5x. 2 minus 5x. Those are our two functions. Right? So this now becomes equal to f of the h of minus 2 first. We're doing this part first. H of minus 2. So it becomes 5 to the minus 2. Well, 5 to the minus 2 is 1 over 25. You can put that in the calculator and work it out if you want. But it's actually 1 over 5 squared. That's what the minus 4 means. 1 over 5 squared. All right? So this becomes f of space under here. So how we can do now, you know? We can actually now take this 5 to the minus 2 and put it here so now, you know, for the x. So to get the f of 5 to the minus 2. That's the one calculation. So it now becomes equal to 2 minus 5. And then where this x is going to put this there in the f function. So 5 times 5 to the minus 2. And you can put that in the calculator, work it out, or you can simplify. This 5 is same as 5 to the power 1. I know like you're multiplying numbers with the same base. So I have to add these powers. So you're going to get 1 minus 2 is negative 1. So it actually becomes 2 minus 5 to the negative 1. 5 to the negative 1 is 1 over 5. So it becomes 2 minus 1 over 5. That's 9 over 5. Because this 2 is same as 10 over 5. 10 over 5 minus 1 over 5 is 9 over 5. 9 over 5. But if you put it in the calculator from up here, so to give you the answer still enough. You're going to write that down, and you put this in the calculator. I'm going to take off this 1 and put it in the red. If you just show it as a power. The 5 was 5 to 1. So if you put that in the calculator, it will work it down for you from right there. If you did this, 2 minus 5 bracket 5 raised to the power of negative 2. Right? Huh? You get that? Yeah? What am I do? It's minus or put plus. Or one never talk. Minus. Right. You get the 1 over 9. Get the 9 over 5. See? 9 over 5. 9 over 5. So you could have got, calculator could have got given you the answer same way. So instead of doing all this work down here, you could have put this in the calculator and get the answer same way. But that is it. You need to be able to do this because it's like a simplification in the way. You don't have to. Huh? Yeah, but it's one decimal they give you a marks, yeah? They give you the marks. Well, 1.8. Yeah, they'll give you the marks with 1.8. That's all right. 1.8. Right? Let's part once. F to the minus 1. F to the minus 1. So we have F equals 2 minus 5x. I want to inverse this. So we inverse this. The F becomes x equals 2 minus 5. And this x becomes F to the minus 1. And trying to make this a subject. To make that a subject, we can take all this got negative and bring it over this side first. And then take this x and carry it over there. So we would get 5f to the minus 1 equals 2 minus x. And then I'll take this 5 and I'll divide it under here. I will get f to the minus 1 equals 2 minus x over 5. And that is it. You can put it by the of x now. Of x. And this is the answer. F to the minus 1 of x. 2 minus x over 5. If you got x minus 2 over negative 5 as the answer, that's still right. Because if you transpose and leave this on this side, that's what I get. But I care about the 2 first and get x minus 2 and then divide by the negative 5. Right? So if you got that, you still got correct. You put this right here, so I could have got this as well. So put it or could have got x minus 2 over negative 5 as our x to the minus 1 of x. Could have got that as well. All right. Done. Next question, so must find f of x in this form. Remember, this f of f could have been written as f squared of x. Meaning the same thing. It means that they put in f into itself. That's what it means. Put in f into itself. All right. So what is f again? F will be 2 minus 5x. So we have f equals 2 minus 5x. We have f equals 2 minus 5x. And so f of f means f into itself. F into f, which becomes equal to. So like if you take all of this f and I bring it and I put it into the other f where the x is right here. That's why I put f into f. And then setting up that construct, you're constructing that. So it's 2 minus 5, where this x is now putting all of the f there, which is 2 minus 5x. And then simplify it down. So it's 2, and then it's minus 5 times each of these values now. So minus 5 times the 2 first is minus 10. Then minus 5 times minus 5 becomes a plus 25x, plus 25x. And then the 2 minus 10 is negative 8 plus 25x. But they want it in this form, which it is. It is in that format. Right? And they said determine the value of A and B. So because I'm saying determine the value of A and B, you're going to write. This is in the form of A plus bx. So based on that, the A is equal to negative 8 and the B is equal to 25. And that is the answer. It's about determining the values. That is it. Very good. But all right. All right. Now we come to number 6. It says the mass in kilograms of 120 newborns at a hospital is recorded in the table below. All right. So this is the mass, and they give you boundary values. See, they have given us boundary values. And these are the mass. So the boundary values are, notice this boundary and this boundary are the same. All right. So this one goes up to, including 3.5. This one starts at greater than 3.5. So these are the boundary values that we were given. It says state the modal class. The modal class is the one with the highest frequency, which is this one. Modal class. What is that? Modal class. This one, the one with the highest frequency. This one, modal class. One with the modal class. One with the highest frequency. And the frequency is 30. So we're going to write this out. So it's 4.4 less than m less than or equal to 5.3. That's all in kilograms. Make sure you state that it is in kilograms as well. Everything important. Put the kilograms on it. That's the modal class. Better go to that. But all right. Good. Next one. Complete the table below and calculate an estimate of the mean mass of the 120 newborns. So we need to fill in this, and that. So they have started the work for us. Remember, when the data is group, you're going to use a class midpoint to represent the group. So midpoints. So all we need to do is look at how these values increasing. These lower values increasing by what? 0.9. The difference is going to get 0.9. You can see it here as well. It's increased by 0.9. So this will increase by 0.9 as well. All right? They increase it by 0.9. Do have to calculate. It's the average of these two values, yes. We can just increase the values by 0.9. Once the value is going up, once the value is going up by 0.9, just continue increasing by 0.9. So we're gonna add 0.9 to this one to get this one down here. So it's 4.85 plus 0.9. That's 5.75. Add 0.9 to this as well. So it's 6.65 plus 0.9, 7.55. Then now to complete this, we need to multiply these values to get this over here. Right? See, you multiply those values, a sum column. So multiply these two. And what did we get? 5.75 in 7. 5.75 times 29. That gives 166.75. Then multiply these two again to get the sum value over here, which is 7.55 times 8. That gives us 60.4. Then we need the sum of this value. This is the sum of F. The sum of this is 120 as the total number of babies, newborn. And with the sum of FX, which is the sum of the sum column. Sum of FX. If we sum all these values now. So I'm going to add up all of them. So it's 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4. That works out to be 651.3. And so the mean is this divided by that. So the mean is 651.3. Sum of the values divided by the total frequency, which is 120. Now work that out. So we're doing 651.3 divided by 120 newborns. I'll get 5.4, 5.43. 3 significant figures with 5.43. I have to say kilograms. Remember the data is in kilograms. That is it. Very good. All right. Let's continue. It says one newborn is chosen at random from the hospital. Once you hear that, you know it's statistics and probabilities. Find the probability that the newborn has a mass greater than 5.3. So you want the mass to be greater than 5.3 kilograms. So you want to know how many of the students had a mass greater than 5.3. You go on the table and look and you see it, right? So you're going to look now for the greater than 5.3. So greater than 5.3 start here, so right here. So M greater than 5.3 start right here, so you can see it. And then everybody after that greater than 5.3. So you want all of these. Not just in that group, all of those. So you want all of these greater than 5.3. So 29 plus 28 plus 8. All right. So the probability of greater than 5.3 is equal to 28 plus 29 plus 8. So 29, 29, 28, 29, 28, 8. 29, 28, and 8. Divided by the 120. Work that out. All right, so that's fraction 29 plus 28 plus 8 divided by 120 students. Give it as a fraction. It's 13 over 24. 13 over 24 reduces to 13 over 20. That's it. Next part says, complete the cumulative frequency table below. So we're going to add up the frequency now. So we need the frequency values. All right, so we need to see what the frequency values are. These frequency values, we need them. So it's 7, 18, 30, 29, 28, and 8. So we need all these values so we can add them. Get the cumulative frequency. All right, that's the frequency values. Out in the cumulative frequency, so we're adding up all these values. All right, so the 7, we have understand that. So now we need to add the 29, right? But this time we're going to add the 29, the next value, right? So we're going to add the 29 to this. So it's 55 plus 29. That's 84. Then 84 plus 28. 84 plus 28. It's the next one. So we add 28. You get 112. And then you add 8. The last one, you add 8. 112 plus 8. That's how we get the 120. And so those are the values. Let me shift this down. It's coming out to here. It's coming out to here. It's coming out to here. This goes up to there. This goes up. All right, something like that. So I've added the frequency values. So that's the cumulative, those are cumulative frequency values. Then it says, on the grid below, draw a cumulative frequency curve to show the information in the table. So they've actually started some of the points for us already. We need to put in the other points. Let's put them on in the red. So you notice they are putting on those upper boundary values. So it's less than or equal to the 3.5. See? Less than or equal to the 3.5. See? Less than or equal to the 3.5 is 7. Then less than or equal to 3.4 is 25. They give those already for us. So the next three values we have to put in is the 84, 112, 84, 112, and 120. 84, 84, 112, and 120. That's the next three values I must put on those boundary values. All right. We need these values to go with them. 6.2, 7.1, 6.2, 6.2, 7.1, and 8.0. Those are the points of plotting. All right. Those are the points of plotting. Let me shift it down here so you can see better. Those are the points of plotting. All right. So we want 6.2. So we'll check the scale now, guys. We'll check the scale. This is 2.5 and this is 2.5 and that's 3.5. So it means that this is 2.5, 1, 3.5. Or 2.6, 2.7, 2.8, 2.9, 3, 3.1, 3.2, 3.3, 3.4, 3.5. So each of these lines is 0.1. So each of these lines is 0.1. So this is 0.1. 0.1. Each of the lines is 0.1. So make a note of that horizontally. Vertically, each of these is what? 2, right? 2, 4, 6, 8, 10. So our vertically, each of these lines is 2. Make a note of it. All right. So we're looking for 6.284. 6.284. 6.284. This is 5. This is 6. This is 6.0. Let's put 6 on it. 6. So 6.2 will be right here. This will be 6.2. And 6.2 going up to what? 84 said? 84. Put this out the way, Mr. Shaw. 84. So 84 would be right here. 80, 82, 84. So 84 is on this line. That's a 84. Coming across on this line for 84. And you are on this line for 6.2. So you're coming to right here for this point. The next one is 7.1. 112, 7.1112. So we're 7.1. So right here will be 7. This will be 7.1. So coming up on that line, we want 112 next. Shift this out the way again. 112. So 110 here, so 112 will be right here. This will be 112. So you're coming across on this line. I also want to say want again. I want 7.1. So 7.1 is on this line up here. So we're talking about this point right here. So the last point was 8.0120. 8.0 is right here. That's 8.0. That's on this line. Can't miss it. And 120 is right at the top. So we're talking about this point up here. So right, 8.0, 120 right up here. So those are your points. Those are your points right now. All right. So you're gonna start to draw a smooth curve. Did we miss out that point? Like we miss out that point in here. So after the it's just 6 points you have. Let's see, 6 points you have. Yeah, only 6 points. All right, so that big jump. All right, that is it. So you're gonna draw a smooth curve through these points, guys. And then they bring the graph down to 0 for us. They bring it down to 0 at 0. Is that correct? The value before 3.5. Let's look back at it. The value before 3.5 would have been 1. Let's see what it would have been. So it's not 0 enough. Not 0. Before 3.5, I subtract 0.9. So when the frequency is 0, the value before 3.5 would have been m less than or equal to subtract 0.9. These are all increased by 0.9. So it would be 3.5 minus 0.9. That should be 2.6. Should be 2.6. This going up by 0.9, that's right. Yeah, man, 0.9. 4.4 minus 3.5, 0.9. Right, so it will be 3.5 minus 0.9, 2.6. So the value before that would have been 2.6, and that our frequency of 0. Right? So the point before that's supposed to be really 2.6, not 0. So that on the x-axis should have been 2.6. So they have this at the wrong. They have this at the wrong place. This is not right. 2.6 is here. That's where this point should have been. Not here, so not 2.5. Right? The value before 3.5 is supposed to be 2.6. So it's this way this point should have been. So this is a wrong point. That point is not correct. And what this point means, remember, that none of the newborns measure less than or equal to 2.5, 2.6. But it's a less than or equal to graph. It's a less than or equal to graph. Less than or equal to mass. Right? See there? Less than or equal to mass graph. See there? Less than or equal to. So it shows how many newborns measure less than or equal to these mass values. So this means that no newborn, but the number of newborn from this line is 0. So this point means no newborn, no newborn was less than or equal to 2.6 kilograms. None of the newborn measure less than or equal to 2.6 kilograms. All of them was over 2.6 kilograms. That's what it means. All right? That's what it means. That point. So that should come down to that to be. So let me draw it in red. I'm going to draw it in blue. Draw it in blue. So I'm just going to try to draw a smooth curve with those points the best way possible on this device. I'm going to go like so. 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 I'm going to All right, eh? Huh? Is that point for 5.3? Oh, that's what I was asking you. Oh, because this one, I thought that one was one of them. All right, good question. All right, thanks for that. So 5.3. So 5.3. Oh, they didn't show this one for us. I thought they gave us two. So 5.355. No problem. 5.355. So 5.3 be right here and 55. So up on this line is 5.3 line and 55 gonna be right. This 55 gonna be right in between here. Because this is 54, 52, 54, 56. So 55 we're gonna be right in between here. So we're talking about this point. All right, thanks for that. I was counting the points. Seeing that gap look a wide, but anyway, that is it. So we're gonna draw the curve. So we're gonna draw a smooth curve through those points. That's it. I'm gonna leave it that. I'm draw it again. Looks so good. Let's draw it again. All right, I'll work with that. That's it, okay. All right, and then I'm sure they're gonna want you to find something from it. Most. All right. So they want us to say, use your graph to find an estimate for the median mass. So the median mass corresponds to the 50 percentile. Right? Q2. Q2, the second quarter. The median mass corresponds to Q2. All right. So the position of Q2 is a 68th student. Right? 68 baby because 120 baby in all, portion of it is right here at 60. This is the position of Q2. Position of second quarter, which is the median. That's not the median, it's a position of it. Forget the median, but come across on the graph. Looks like it is right inside here. Looks like it is 5.5. Everybody get that? That looks like Q2. That's what I'm getting, 5.5. Maybe a little bit less, but I work with that. But as an estimate, right? So but the answer is going to be a little bit different depending on how you sketch a graph. So it's an estimate, remember. So Q2 is approximately 5.5 kilograms based on my graph. All right, that's easy. All right, next question. Number 6, a measurement question. Question said, I want to say pi, we're going to do some circular measures, right? It said the diagram below shows a hemispherical bowl and a cylindrical tin. The diameter of the cylindrical tin is 12, so to give us the diameter, we're going to work with the radius. Let's call that the radius of the cylinder is 6 centimeters. The diameter is 12, the radius is 6, working with radius. It says, and the height is 17 centimeters, and the radius of the bowl is R. So the radius of the bowl right here is just R. See there? Radius of the bowl is R. It says, show that the volume of a cylindrical tin is this. Character 4 significant figures. Now remember, volume of a cylinder is pi r squared h. Area of the base times the height. I think that formula, that is on the formula sheet, but you should know. The volume becomes pi r squared h. I talk about radius of the cylindrical tin. So that volume becomes pi, which is 22/7, times the radius, which is 6 squared, times the height, which is 17. And put that in the calculator, and you should get that value that they gave you. All right, so it's 22/7 times 6 squared times 17. See? 1923. 1923 centimeters cube. I've shown that. Next part says, the bowl is completely filled with soup. The bowl is completely filled with soup. When all the soup is poured into the empty cylinder, 90% of the volume of the, let's go again. When the soup is poured into the empty cylindrical tin, 90% of the volume of the tin is filled. Okay. So 90% of this is filled. It means that the volume of the bowl is 90% of this. That's what it means. Now the bowl is completely filled, right? Calculate the radius of the bowl. And the radius of a sphere is 4/3 pi r cube. The bowl is half of a sphere. So the volume of the bowl, first we have to really, note here now that the volume of the bowl is half of this. 2/3 pi r cube. Half of the volume of the sphere. See that? The bowl is half of a sphere. So the volume of a whole sphere is this. The volume of a bowl is half of that. Right? Half of this. That's what this is. Half of this. Half. The bowl is half of the sphere. All right? So what I mean that the volume of the bowl equals 90% of the volume of the cylinder. That's what this means, you know. That's what they say. So the volume of the bowl equals 90% times the volume of the cylinder. That's what is that. The volume of the bowl is this formula. So it's 2/3 pi r cubed equals 90% times the volume of the bowl, which is this, 1923. And from this equation, we're trying to find the R of that equation, where this pi is 22/7. Trying to find the R. Okay, just simplify it down and work it down gradually. So it will be 2/3 times 22/7 times r cubed, that is now equal to 90% of that. What 90% of that is? That's 90%, if you get the exact value, times 1923. So we're getting 1730.7. We have to find the R now, we're going to transpose now to make R the subject. So when I take these two values, which becomes 21, multiply it up here, take these two values, which becomes 44, and divide it under. But I can't say that. Good? So we're going to end up getting R cubed. This right. Must be as well. Make this smaller. All right. Okay. 6, you don't give out that space to work, you know, so to be very efficient with their work, as you can see. Right, so we're gonna have R cubed now equals 1730.7 times this 3 times 7 is 21. I'm gonna multiply it up here so beside it. So multiply that by 21 divided by this 2 times 22 is 44, and divide it under here over 44. And then if this is R cubed and you want R, you're gonna have to cube root both sides. So we're gonna cube root this side and cube root this side as well. That's square root and cube root this side. And it's that the cube root cancel the cube, leave us with an R over here. And then we'll work this out to get what that value of R is. So it becomes the cube root of a fraction 1730.7 times 21 over 44. I'm getting 9.38. Did they tell us what accuracy they want for the radius? No, that's going to get 3 significant figures. 9.38 centimeters is the radius of that pole. What I go to that? 9.38. You never get it right, go and do it over. Go and do it if you never do it. All right, next question. Next question gives us this semicircle. It says in the diagram below, points L, M, and N are on the circumference of a semicircle, half of a circle, with center O and the radius is 18 centimeters. All right, let's put that on. Radius is 18 centimeters. Means that right here says 18 centimeters. Right here says 18 centimeters. Here says also 18 centimeters. This line is also 18 centimeters. And that's a radius. Anything from the center to the circumference is a radius. So these three lines are 18. It means that this base down here so is 36. 2 times 18 is 36. Question says, calculate the total area of the shaded diagram. Let's go again. Calculate the total area of the shaded section in the diagram. So on the area of this shaded section. Simple. Become the area of the semicircle minus the area of this triangle inside it. But after that, to get the area shaded is the area of the semicircle, which is half of a circle, minus the area of the triangle. So the area shaded equals area of the semicircle minus area of the triangle inside it. Area of a semicircle is half of pi r squared, because the area of a circle is pi r squared, right? So this is half of pi r squared as a semicircle minus the area of the triangle is half the base times the height. Let's write them out. So it becomes half the base, which is Ln, times the height, which is OM, times OM. Put in the values now. The pi is 22 over 7. So it's half times 22 over 7 times the radius. Radius is 18 times 18 squared. That's the other semicircle. Minus half. Ln is 36. Ln is 18 plus 18 is 36. But I can say that Ln is 36. See there? Ln is 18 plus 18, which is 36 centimeters. So Ln down here is 36. And the OM, which is the height of the triangle, is also 18 because radius. Right? It's recognized that that's also a radius. Put all this in the calculator, we'll get the answer, right? One time. Put this all in the calculator, and it will tell us the answer. We have to work it out part by part. So it's a half times 22 over 7 times 18 squared minus half again times the base of 36 times the height of 18. That's 185. 185.14 centimeters squared. That is it. Is the area shaded. Are you okay with that? But good? Anybody got it? Anybody got it in the test? Come on, the compound shape are easy. You know, the shaded region is the semicircle minus the triangle. Simple. Shaded region is the area of the whole semicircle. Subtract the triangle from it. Leave you the area shaded. It should give you guys any problems, man. Come on. Compound shapes. All right. We need to go and do it over. It's the same question on this page. So this page is repeated. Page 19. All right. Let's continue. All right. Come to a pattern question number 7. Said the diagram below shows the first 3 shapes in a sequence which form a pattern. It says each shape is made using a set of small white counters and black counters. All right. That's what is that mean. So to go from one shape to the next shape, we have to observe what is that. So what happened here is that they added a black on both sides of this. and on both sides of this, and then one at the top, and then I added circles on either side of this, the white ones on either side. See that? So they basically add these things around it and put them in blue so you can see. So go from this to this. Observe. This then became 5. This was in the middle. This is the original shape here, so. This is the original shape. Also, they also add on the bottom. So that the other line on the bottom as well. All right. So let's look again. So you have to look how it changed, you know. So this is the original shape, which is inside here, so. Yeah, that's the original shape. So these things are all around, it was added. But I can see that. So if you see what the original shape was and see how they go to the next shape. So all these dots around it was added. So they keep adding dots to the sides, above and below, right? All around. All right. So we're adding dots all around. And then you see, we go from this one to this one, the same thing they do. They added black dots around this. And one on top, and then they add the white dots around here. That's how they got that one. See that? See it? All right. So adding all the way around. So around the black, we're adding black. Around the white, we're adding white. So what they have done, they have drawn figure 3 for us, and they want us to complete it to get figure 4. So we have to do the same thing. Just add the dots all the way around. So on the top, we're adding black dots at the top. One up here, one up here, one up here, one up here, one at the top, one over here, one over here, one over here, one over here. Those are the black ones we're adding. I'm marking them in blue so we can make the distinction, right? That's what we're adding. Then all the way around the white section, we're adding white counters them called it. So all the way around the white, now adding white counter. So we're adding a white counter here, a white counter here, a white counter here, a white counter here. Now going below this as well. And that is your next key. That's what you should have. So you're adding those things all the way around it. You get the next shape based on the pattern of how it is formed. So you have to be able to observe and see how the pattern moves. So they go from one shape to the next shape. Right? You're adding all the way around. Want to go to that? All right, good. Now go to the table now. And the beauty about this, a lot of the time you can do the work without the pattern. You can do the calculation on the table without the pattern. You can write the table on its own. You don't need the pattern to help you. It says the number of white counters W and black counters B and the total counters T that form each shape follow a pattern. The values of W, B, and T for the first 3 shapes are shown in the table below. So the pattern of numbers for each row in the table and answer the questions that follow. You want to complete the rules for 1, 2, and 3. Always that is the case. And as always, I like to do the formula line first because it helps you to appear sometimes. You do the formula line first. So to the formula line, we're going to observe the patterns, right? All right, so what do we notice here? The good thing that they give us this one. They give us this one, so we have to figure out that one. All right, let's look at this one first, the first one. So these all match the shape number. The shape number is also here. All right, so the shape number plus 1 first. So the shape number plus 1 says n plus 1. And then inside, is 2 times the shape number plus 1. That's 2n. So here it says 2n plus 1. 2n plus 1. But I can say that. Then over here now is the shape number always come first plus 1. The shape number plus 1. And the shape number is n. down here. So it becomes n plus 1 squared. So down here becomes n plus 1 squared. So they're helping us. And then this one is already completed for us. Beautiful. So once we get that now, we're good. So for this one now with the n is 4, it's the next shape. So we're going to take the form, put on the formula down here. So I must work out what actually it is in the end. So it becomes 4 plus 1 squared. So it becomes 4 plus 1 squared. That's 5 squared is 25. And then over here now, we need to put the 4 down on this formula. And work out the value for here. All right? So this row is when the n equals 4. So it's going to become 3 times 4 squared plus 5 times 4 plus, but this is the total, so I cannot add up these. It's the total, you know, I waste time. Remember, T is the total. You can check it. Just add up these, add up this plus this. Huh? 70. Let's add them up. So it's 45 plus 25. It's a total, 6 plus 4. See it? I was trying to do the formula. I don't need a formula because the total. So it's become 70. And then for this one, the total right here says 420. Then you can subtract this to get this. But anyway, you're putting back the pattern. So we're right by the same pattern. So this is now, all right, the first thing to get the n over here, to get n over here, we're gonna put this formula equals this, right? In this line. So for this line, we're gonna write to get the n, we're gonna put that the n plus 1 squared is 144. So it's n plus 1 squared is 144. So it means that the n plus 1 is 12. So it means that n plus 1 is 12 because square root of 144 is 12. And then subtract 1 and get n equals 11. So right here so it's 11. And when right this so it's 11 now, you put out the formula, right? It becomes 11 plus 1 times 2 times 11 plus 1 equal. What I work out to? You can work it out by doing the subtraction. How much? 276? 276. If you add this to 276, you must get back that. All right, 420. All right, 276. And the table done. I've completed everything in the table. All right. All right, next question. It says, the expression for the total number of counters, T is W plus B, in S shape is given as this formula. In shape S is given as that formula. It could have been shape N as well. So the same formula that we have in the table right here. So, you know, 3n squared plus 5n plus 2, same thing. Oh, so you say they put A and B here. So A and B. A and B. So why not related to that? So the A is supposed to be 3, and the A is supposed to be 3, and the B is supposed to be 5 when we're done it. But anyway, let's say this is the formula, right? All right. It says where A and B are both positive integers. By substituting suitable values for S, so the total counters in shape 1. So shape 1 is when S equals 1, and shape 3 is when S equals 3. So that these are two formulae, respectively. So I plug them two values here into this formula right here. So as simple as that. All right. So for shape 1, S equals 1. So S equals 1. You plug 1 in this, you're gonna get A times 1 squared plus B times 1 plus 2 equals. And in shape 1, the total was what again? Total was 10. Remember that? Shape 1, the total was, S equals 1, the total was 10. Total was 10. That's equal to 10. All right. So you get A plus B and subtract the 2 over here. So you get A plus B equals 10 minus 2. So A plus B equals 8. So remember, when S equals 10, when S equals 1, the total was 10. And when S equals 3, the total was what? S equals 3, total was 44. Total was, is 44 that? Yeah, 44. Total was 44. That's what you put in. When S equals 1, the total is 10. So you put the expression and put equal 10. So you get the first equation. So this one is shown. Got that one. Second one now is when S equals 3. So when S equals 3, total is 44. So we're going to put the 3 in this formula right here. So it's gonna be 8 times 3 squared plus b times 3 plus 2, and that works out to be 44. 44. So this now is 9a. That's 9a. That's 3b. And take this 2 and carry it over here, so subtract it. You're gonna get 42. And subtract the 2. Then this can be divided 2 by 3 now. So we divide this 2 by 3 now. Divide by 3. You're gonna get the equation that I tell you. Divide this by 3, you're gonna get 3a. Divide this by 3, you're gonna get b. And divide this by 3, you're gonna get 14. And so this is also shown. And so this one look a bit different, but that's how it is sometimes. So I've shown the two equations that I want. All right. Let's continue. Like a standard. Then we come to section 2, and that's a conjunction. That's an easy. And they give us a graph with it. This question says, diagram below shows a graph of two functions on the same pair of axis. You have function g, which is this line, function h, which is that. And the end of those two lines. It says, determine the equation of line g, equation of this line. To find the equation of that line, the gradient and the y-axis intercept. So for line g, this is the y-axis intercept right now. It's 3. So c equals 3. Right? They want the gradient. You can use this point to this point to get the gradient. Let's count it off. So to go from here to here, or is the right and the right? Let's put down in blue. You have to rise up here, so. Rise up here, so. And then run across here, so. So the rise is 3 units, you rise. So the rise is 3. And you run across here, so 6 units from -6 to 0, 6 units. So you run 6. Run 6. So it means that the gradient of line G, is rise, put it down the question. So for line G, C is equal to 3, and the gradient is rise 6 over run 3. 6 over 3 is 2. I'm using y equals mx plus c. Easy. So the y becomes, the gradient is 2x, and the c is 3. Yeah? Huh? Probably the wrong way around? Okay, thanks. Probably the wrong way around. So the half. Beautiful. Oh, you're bright. You rise 3 and you run 6. So that's a half then. You are bright. So the half x plus 3. All right, good. My mistake. Rise 3, run 6. All right, beautiful. Good. Next question said the equation that represents line H. All right, so we're going to find line H now. So we're going to do a similar thing for line H. Now, what do we know about line H? They said that they're perpendicular. They tell us that they're perpendicular. So they have negative reciprocal gradient. And then line H passed through this point. The line H passed through this point. And that point is called P is the point 40. That's line H passed through that point, right? And the gradient of line H is the negative reciprocal of gradient of line G, right? So let's call this MG. So we can make the distinction. So let's call this MG, MG. All right? So down here now, gradient of line G, gradient of line H is minus 1 over the gradient of line G. Over the gradient of line G is a half, right? We have to calculate it because they didn't tell us, but they tell us that the perpendicular. That's because G is perpendicular. Let's put it on here, sir. G is perpendicular to H. That's why we can say this. And so to get this perpendicular gradient, flip this and change the sign to become -2. The line H also passes through the point 40. That we'll have on the graph. It passes through the point 40. And to find the equation, we get the gradient at that point. And the point is 40 in that diagram. So the equation becomes y minus the y value at p equals the gradient of line H into x minus x value at p. We're using this formula this time, but we don't know the c. So the y minus the y value at p is 0 equals the gradient is -2. The gradient of line H is -2. Into x minus x value at the point is 4. And so y minus 0 is just y equal -2 times x is -2x. -2 times -4 is a +8. That is the answer right for line G, line H. Right? So this is line H. This one was line G. All right. So now says, oh, let's up. Oh, so they give us a different point P on the diagram. So we can't call this P then. Let's change this to Q. Cannot call this P as well. They give us a P as well. Didn't realize. So I'm gonna call this point Q. Call it something different. Call this point Q. So all these become Q. This becomes a Q, that becomes a Q. All right, so what they say now, calculate the coordinates of point P, and point P is the intersection of the two lines. See that? So to find P, we solve the two equations simultaneously. So P is the intersection of the two lines. So at P, two lines valid at P. So at P, first line is y equals what? Half x plus 3. Y is equal to half x plus 3. And second line is also valid. Y is equal to -2x plus 8. Solving those two simultaneously. So at the point, the two y values is the same. So therefore, we can equate these two things. And the two y values are the same at the point. I'm solving them simultaneously by whatever method. So I can say, therefore, half x plus 3 becomes equal to -2x plus 8. Multiply 2 by 2 first to get rid of the half. Let's simplify it by multiplying by 2 first to get rid of that fraction. So multiply this by 2 becomes x. Multiply this by 2 becomes 6. Multiply this by 2 becomes -4x. Multiply this by 2 becomes 16. Carry this first over here, add it to this, we get 5x equal, carry 6 over here and subtract it. 60 minus 6 is 10. And so the x equals 2. If x equals 2, we can take the 2 and substitute it right here. So for this x, so we can say, and at the same time, the y becomes, put the x right here, the 2 right here for the x, I get half of 2 plus 3, which is equal to 4. So therefore, P is the point 2, 4, 2, 4. I can try the x equals 2 here as well. It will be -4 plus 8 is still 4, which is correct. So P is the point 2, 4. They basically have to solve the two equations simultaneously by whatever method. I just use a method of equating the two y values because they express both in terms of y. At the point P, the y value is the same on both lines. So therefore, you can equate this expression for the y on one line with the other expression for the y, y value is same. And that works out until what the x value is at that point. All right, and that is it. We basically just solve them simultaneously. So that is done. Next question. Write this in the form a into x plus h squared plus k. There are some teachers teach you with the actual h and k, but I use xt and yt. That xt is x value turning point, yt is y value turning point. So we're going to be using, instead of this, we're going to be using a into x minus xt squared plus yt. There's a formula for the xt and a formula for the yt. The xt is minus b over 2a. What is the a and the b and the c? Let's get them from this. The a is the coefficient of x squared, which is 4. The b is the coefficient of the x, which is negative 24. And the c is a constant term, which is 31. So plugging them in this now. So minus b over 2a. So it becomes minus and negative 24 over 2 times a, which is 2 times 4. That becomes a positive 24 over 8, which becomes 3. Now, normally, when you get xt as a whole number like this, you can find yt by plugging the xt value in the function, in the expression. So you can get yt by just plugging the 3 back in this now, rather than use a formula for yt. When you get a whole number value for xt in particular, you can do that. So now, let's do that. So the yt is going to become 4 times 3 squared minus 24 times 3 plus 31 equal. They don't give a lot of space to work, guys. Notice that. They don't give a lot of space. So expect it to work very efficient. So it's 4 times 3 squared minus 24 times 3 plus 31. That is negative 5 for yt minus 5. So the function then becomes this. So therefore the a is 4 into x minus the xt is 3. Don't forget the square, and the plus yt is negative 5. That's your answer for the expression. This thing is the answer for the expression. That's the expression right there. All right? Expression of the one. And then I must do a sketch now. It says, on the axis below, sketch a graph indicating the coordinates of the maximum or minimum point. And we know it's a minimum point, it's not a maximum, so we can cross this out. But we know it's a minimum, but the A positive, right? So we have a minimum point. And that minimum point is xt yt, which is 3, negative 5. That's where it turns. The y-axis intercept is that 31 up there, right? So it also passes through the c value. The y-intercept is 0c, which is 0.31. And that's a smile shape. Right? That's my sheet. So this minimum point is going to be somewhere down here. So 3, negative 5 is going to be somewhere under here. So. And across the y-axis is at 31. So it's going to be somewhere up here. So turn down here and cross somewhere up here. So. And it has a smile shape. That's what you have to draw. Right? So the graph is going to look something like, as a sketch you're doing, you're just going to draw something like that. Right? Now put this point here as 5, negative, not 5, 3, negative 5. Put that as 3, negative 5. Put this point as 0.31. Y-axis intercept, C value. That's a sketch. So that's just show the minimum point, which is here, and the y-intercept is 0.31. So this is the y-intercept. Let's write it out. So this is the minimum point. This is the y-intercept. And that's a sketch of the graph. I label it up like sketch of y equals 4x squared minus 24x plus 31. That's what this is. That is it. Very good. Next partner says state equation of axis of symmetry. X equals xt value. Remember? So x equals whatever the xt value is. So therefore x equals 3. Okay, I'll show it on the graph. It's a vertical line through here. It's the axis of symmetry. It should be axis of symmetry. Shift is over. So this is going to be the axis of symmetry. I go all the way up, you know, draw it all the way through. So go all the way through the graph like this. That line. That line is a line. X equals 3. That is the axis of symmetry. This line is the axis of symmetry. This is the equation of it. X equals 3. Divide the graph half an hour. Passes through the turning. Equals 3. Done. Number 9. Number 9 says K, L, M, and N are points on the circumference of a circle, center O. X, Y is a tangent to the circle. At K, angle LKY is 48 degrees over here. And angle MOK inside this is 12 degrees. And angle XKN is 56 over here. All right. It says find the value of angle KOL. Find the value of angle KOL, which is the angle right here, so the want. At the center. All right, we're gonna get that angle. So that angle is subtended by this chord. That chord is making an angle of 48 degrees with a tangent. So the chord will subtend the same angle of circumference up here. So this angle is also 48, just like this. But the one at the center is twice. So I'm going to show you the sequence of operation. Watch it. Zoom in and show you. So the angle between this tangent and this chord is 48 degrees. So it means that the chord will subtend the same angle at 48 degrees at the circumference. So then this angle up here is 48 degrees. Subtended by this chord. See? 48 degrees. Subtended by this chord. Same chord is subtended in this angle at the center. The one at the center is twice. So this angle in here becomes 2 times 48 degrees. Because angle at center is twice angle circumference. That's what I want to use. All right. So I want to tell you that this angle is 48 degrees first. Equals angle between tangent and chord equals angle subtended by the chord. That's why that is 48 degrees. So I'm leaving that. Then I'm going to tell you that this angle is twice that one. And angle at center is twice angle at circumference. So this angle down here now that one. So I'm leaving this on my diagram as a part of my answer. So the angle that we want down here now is angle KOL is 2 times the 48 degrees that I put on the paper. Which is how much is that? 96 degrees. Reason, angle at center is twice angle at circumference. And that is it. Next angle that I want is what? Next angle is to find each of the following angles. So here, we don't want to write no reason. Let's find them. See, just one mark. So up here, they want you to give reason. But down here now, they just want you to think. So I guess this is 2 marks because they expect to find this one first. And then that. But there's a rule that could have given us this one straight enough. Was all right. So this angle here shows 96 degrees. Let's put under that. 96. All right, 96 degrees. Now down here, I just want to calculate these angles. And I really need to put a reason under that. We're going to put reasons too. Angle LMN. LMN. Where is that? Angle LMN. That's everything across here we want. Everything over here so we want. All right. Angle L and all that. So we might need to find this one first so we can add on to the 48. All right, let's do that. All right. So you see this angle right here, so now let's put on in blue. It's subtended by this form. See it? As we come back along the sides forming the angle which is circumference. This chord is subtending that angle up here. But that same chord is subtending that blue angle. It's making an angle of 50 degrees, 56 degrees of the tangent. So it means it's subtending the same 56 degrees. So I mean that this angle inside here, so it's 56 degrees. And then the total angle across here, so then is 56 plus 48. See that? I'm going to tell them about this one first. That this is because, again, same reason as this. So we can just copy this one. I'm going to tangent and chord, paste it here, so and change it to blue. Same reason. Come on, device. Same reason, change it to blue. So we can make it thinner. And that's it. All right. And then the angle that one becomes 56 plus 40, right? They want this angle, you know. They want this angle. This angle. LMN is already some of those two. So it's 56 plus 48. So this angle becomes equal to 56 degrees plus 48. What are we about to? 64 degrees. Which angle I want next? Angle KLO. Angle KLO. Where is it now? KLO. So I want this angle down here somewhere. Put that one in perfect. I want this angle now, right? KLO. Oh, guess what now? That angle is one of the angles in this isosceles triangle. It's an isosceles triangle. Why is it isosceles? Because this radius, that's a radius, is the same length. So it means then that this angle and this angle is the same. Those two angles are the same. So you can work in this triangle, so total angle in the triangle is 180, and then divide by 2. So 180 minus that divided by 2. Or you could find this one, because that one equal to it. And this one right here is going to be 180, it's going to be 90 minus 48. Why is it 90 minus 40? Because the angle between the tangent and the radius right here, so it's 90 degrees. And if part of it is 48, then the other piece inside here is 90 minus 48. And this angle happens to be equal to it as well, because the axis is stronger. So that's what we're gonna do. Let's do it that way. So when I first say this angle inside is 90 minus 40. This one is 90 degrees minus 48 degrees. What is that? 42 degrees. That's because tangent and radius, right? Angle between tangent and radius. You don't know so. And radius is 90 degrees. That's why that angle. And then this angle not equal that one over there. So this angle equal the same thing. That angle equals 42 degrees as well. That's because we have an isosceles triangle, right? That's because triangle OKL is isosceles. Isosceles. So its angle is 42 degrees. So let me write it down. 42 degrees. See diagram for the reason.
Sir.
Yeah?
So for the previous question, for angle LMN, it's
Huh?
104 degrees. For
Huh?
angle
Oh, it's
LMN,
plus. Is what? Which one? This one.
LMN, sir,
Thanks. How much is it? I them tell me 64 and
104,
I know. Is it much?
104 degrees, sir.
I don't want to beat I do the stick in there. So I don't even look at it. 104 degrees. Thanks here. This is
Yes,
what I'm
sir.
64. You. Oh Lord. I didn't even look at the numbers. Thanks for that. Oh boy. All right. So that is it, right? 42 degrees. I stop just and I said my wife. All right. I didn't even look. I just took the figure that they tell me I wrote it down. All right. 42 degrees. 42 degrees. All right. So that's what says. See the diagram for this reason, right? It's on the diagram. The next one now is MLK. So many angles they ask. That's why they don't even know one month. They don't want you to write it. Just calculate it. MLK. Let's see where that is now. MLK. 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 So now the one, all of this angle marked in red. Or all of this angle, yes or no? MLK. That's the angle that I want in red. MLK. All right, so to get that angle MLK now, what we can do, so we can do. Um, to find that angle MLK, you can work in this triangle right here, so. You can work in this triangle that I'm going to mark out now in red. All right? I'm going to say these three angles are up to 180. So we're going to do that, with this angle right here, so. All right? And that angle right there, so, is actually 42 minus 12. See that? Remember, the whole of this purple angle is 42. The whole of this purple angle right here says 42. And this part of it is 12. The remaining piece of it must be 30. See that? See that? Must be 30. All right? If all of this is 42, and this part is 12, then inside so must be 30 degrees. And then these three angles now add up to 180. So this other angle that I want, right here, the red angle that I want right here, becomes 180 degrees minus 48 and the 30. What I work out? How much? I'm not sure. Let's just again, 102 again. All right. 102 degrees. And I said my wide, which other angle was 102 again? So no place was 102. Keep them related. Anyway, I'm bother with that. 102 degrees. All right. So I'll put this calculation on the next page. Down here, so for this one. All right. And then they want angle, K and M. Let's see where that one is. K and M. Angle K and M. Angle K and M. Where's the K and M? So now they want this angle up here. So now let's use a different color. Let's use green. I've not used any green. Let's use this green. So they want this angle now. K and M. So that angle now is subtended by this chord. See it? Don't it? That chord is making this angle with the tangent out here. And the angle between this tangent and this chord now is that total of 48 and 30. See that? So this angle must equal to some of these two angles out here. This angle out here and this angle out here is the same. Because the angle between that green tangent and this green chord is equal to the angle subtended by the chord up here. And angle between these two green lines is 30 plus 48. That's 78. So this must be 78 degrees. But I can say that? Yeah? Tangent and chord. Right? So this chord is subtending that angle. That chord is making a total angle down here. So it is tangent out here. It's total angle. Its total angle is a 30 plus the 48, which is 78. And so the chord subtends 78 up here as well. 78 degrees. See it? 78 degrees. So we can use that. There are other ways to do it, but we can use that. So 78 degrees. All right. So this angle becomes 30 plus 40. This angle becomes 30 degrees plus 48 degrees. Which is 78 degrees. Tangent and chord. Then I really want a calculation. That's why I go, no reason. That's why I do the calculation. No, they didn't ask for any reason. I keep giving 1 mark each thing. Let's equal to 30 degrees plus 48 degrees, which is 78 degrees. There are other ways to do it, but this one good enough. All right. Then we'll come to this question. That question long. This question said E, F, G, and H are 4 points on level ground. So like you're up in the sky looking down at these points on the level ground. All right. So think of you being up in the sky looking down on the ground. It said the diagram below gives information on the distances and angle between the points. Everything is on the diagram. That's what it's going to say. It says show that angle X is 29.5 degrees correct to 1 decimal place. That's this angle X right here. So to get that angle X, we are going to, we're going to get angle X. So what does them tell us? Not yet, everything is in the diagram. All right, so angle X. Oh, I see what it is. We have 3 sides on this triangle. See that? You know the 3 sides. When you know 3 sides on a triangle, it's not a right angle triangle. You want to find one of the angle, use cosine rule. So we're going to use cosine rule to find this angle here. Cosine rule. All right? So we're going to work in that triangle using cosine rule. And when this is the angle, you're going to treat the side opposite to it like your hypotenuse. Start out like this was the hypotenuse, opposite the angle. So cosine rule for the x, not alpha, for the x. So start like this is the hypotenuse, the 6.8. So you're gonna write 6.9 squared equals this side squared plus this side squared. Remember, I'm working in this blue triangle now. And I'm using cosine rule in it. All right. So the 6.9 squared is going to be equal to the 5.3 squared plus the 11 squared. But it's not part of the same, so you subtract a piece. You subtract twice product of these two sides. The 5.3 and the 11, and the cosine angle between them, which is the x. That's what you're solving for x. All right? Now, transpose and find. You need to practice this, guys. That's so often they give you a triangle with 3 sides to find the angle. But practice the transposition of this thing. So you're going to take all of this negative expression and bring it over on the right side and take the 6.9 and bring it over 6.9 squared, bring it over onto the right side. So that expression though going over to the left, and the 6.9 squared going over onto the right. All right. So this coming over here and become positive. So it's gonna become 2 times 5.3 times 11 times cos x equals this stay 5.3 squared plus 11 squared, and then this goes over and becomes a minus 6.9 squared. Then all of this multiply is divided under this side, divided under. So I'm gonna draw the line and divide it. Take this and divide it under, remove it under and show you. And then just divide it under all of this. Divide it under here. Right? And then you have cos x, you have cos x equals this now. And then if cos x equals that, you're going to take the cos and inverse it in front of that. So you're going to take the inverse of the cos in front here. Cos to the minus 1 of everything. And that's where you find the x. So practice it, right? Practice it. So x equals, then we're going to go to the calculator. Practice it, guys. Practice it. So you're going to get cos to the minus 1 for fraction. It's 5.3 squared plus 11 squared minus 6.9 squared. I divided that by 2 times 5.3 times 11. That's 29.5. 29.5 degrees. That has been shown. That's what I said it was. So I've shown it. All right. Hello, I don't know when I'm going. I'm supposed to stay and finish and tell me no grade, you know. I'm saying I take this thing for a joke. Huh? I'm talking to you, you know. What? What is your excuse? What is your excuse? Say that I can't wait. That I don't know what time class over. You know, so I'm going to take this thing for a joke. Your exam is 2 hours and 40 minutes. And you can't do 2 or 40 minutes class. Eh? I'm not ready for this yet, you know. Go on your ways, man. Go on, man. Go on. I know why you're not. Go on. Let's go. It said a vertical tower GT is constructed at the point G and it's pivoted onto the ground. So remember now, you're in the sky looking down at this thing, and they put a vertical pole right here, so at G. Right? So this is coming up into the sky towards you. So you have to imagine this thing and visualize this thing now. A vertical thing is standing here. So if you're standing on the ground, it's like you have a vertical thing standing at G. And these points are on the ground. So on the ground with G. So maybe H, for example, is out here with G. All right? But let's continue to see what they said. So you have to imagine a vertical thing coming up towards it in the sky from here now. So if you're standing on the ground, you will see the vertical thing. Up in the sky, you're not going to see it. Okay, above it, right? All right. They said a vertical tower GT is constructed at the point G and is pivoted to the ground at the points E, F, and H using pieces of wire. So like a light pole, and they bring wires down to those points on the ground, right? To keep it vertical and keep it steady. He said the angle of elevation of the top of the tower T from F is 31 degrees. See it here now? From F is 31 degrees. So F here, so, and G right here, so. So like you have a vertical tower right here, so at G. So vertical tower like this. G on the ground, T at the top. And F is on the ground. I'm going to put F out here. F is out here, so F. The distance from G to F is 6.9. So this is 6.9 cm. And they talk about this is vertical tower. And they talk about the angle of elevation, which is the angle looking up here, so it's 31 degrees to look up. 31 degrees. That's what it will look if you're looking from the side and the vertical tower here. That's what they're gonna see. But you can understand that? Can you understand that? You have to be able to visualize this thing in this question. And then because it's vertical and it's horizontal, it means that this angle is 90 degrees. And so you know we're working on a right angle triangle. I'm gonna ask for the height of the tower, I'm sure. We're gonna ask for the height of the tower. So copy this down and put it down here. So that's the diagram you're working in. All right. All right. Oh, they want the length of the wire. That's what they want, the length of the wire. So the question says, what length of wire is used to pivot F to T? That's what they want. They want the length of the wire. So this becomes the wire. This is the wire. I want to know how long that is. So you have adjacent and you have hypotenuse. So you're going to use cos, right? Cos. Adjacent and hypotenuse is cos. So you're going to write cos of 31 degrees equals adjacent 6.9 over the wire, which is TF. The wire is TF. So to find the TF, we're going to take the TF, multiply it up here, the cos of 31 and divide it under. So we're going to get TF equals 6.9 over the cos of 31 degrees. And then work out the length of the wire right here. People want to do exam and pass exam and don't want to work for it. Cannot take it. And then when they get them failing grade now, they don't remember so they don't sit in the class and learn them to learn. Right? I just can't deal with it. I just can't do the foolishness. People want to do exam and get good grades and they don't prepare to work for it. If CSEC give the grade for free, CSEC is not giving away the grade for free. The length of the wire is 8. This is what the length of the wire is 8.05 meters. 8.05 meters, the length of that wire. You have to work to get the grade. The more work you put in, the more work you do, the better grade you get. For the classroom empty. Everybody each up at 2 and go to my channel. When stop keep this class online, everybody come class. You don't want to work. People just want to go exam and do exam and expect to pass and get good grades. And they don't want to put in the work. For the classroom empty. When stop this parenting online. Because a lot of people who are supposed to be here, by the moment doing the class online, them stay home. They don't come. Right? They stay home. I'm going to stop doing it. Serious. Set the bearing. I'm going to start record it. But I'm not going to keep the class online. I'm going to stop doing it. The bearing of E from H is 228 degrees. The bearing of E from H is 228 degrees. All right, find the bearing of H from E. So let's put this on the diagram and then see what angle they want. So the bearing of E from H. I have to be careful now. So the bearing is measured at from position. So it's from H to E. It's 222, 228 degrees. So let's put on the diagram. H to E. H to E. So it's H down to E is 228. So talking about bearing of this direction. So it is all of this angle that is 228 degrees. I'm marking out in red. 228 degrees, right? So let's say 228, sure. 228. So all of that angle is the bearing of this direction from H to E. That is 228 degrees. Remember, move this out of the way. Make it small and put over here. So that is 228 degrees. And now they're asking us for the bearing of E from H. So I want the bearing now of E from H. So it's from E to H. I want the bearing from E to H first. From E to H. So from here to up here, I want the bearing. So let's look at it. They now want the bearing of this direction, which basically this is the north line. They want this angle. But because all angles we have up here, we do have to force ourselves to calculate it down here. Because to calculate down here, what would have to do? Work out this angle over here so first, which is 360 minus 228, and then note that these two add up to 180 to get this one. But you can more easily get it by recognizing that this direction down here is the same direction if I extend this line up here. So same direction, you know. I want the bearing of that direction. And if I extend this north line up here so you can see it, if I extend this north line up here, you're still talking about this angle right here. That's the same angle, same bearing angle that I want down there. So that angle that I want, same angle that is down here. But the bearing is just a direction. It's a angle, the direction given an angle, same angle that I want. This angle and this angle is the same, they correspond to each other. And how can I find that angle? Easy. But the whole of the angle around here so it's 228. And then from here to here so it's 180. So this angle in here becomes 228 minus 180. You see that? Easy calculation. We do that. One calculation give you rather than to do this and then do all of gymnastics. So the bearing angle that I want becomes 228 minus 180. That's what this angle is. 228 minus 180. What I work out to? What I work out to? 228 minus 180 is the amount. Somewhere on the man. When I get 48 degrees. So it's 228 minus 180 is this one. 228 minus 180 equals 48 degrees. Because it's bearing, I put it here in front, right? 3 digits. Then I want the bearing from H to G now. Let's put that and see, find again. I don't want from H to G. H to G. I want the bearing direction H to G next. So H to G. It's this one. Down here, so. Right? From H to G. Let's put on that one a different color. Purple. So that one now is from this north line CMA down to this line, we take it down to G. So this is another one now, this one. That one, that one. What that one equal to? But can tell me quick. Oh, 228 minus 54. But everything around here so it's 228. But this one stops short of the 54. So it's 228 minus 54, the ones. Right? So it is I want to get that. So I just want to draw this out a bit better. So the bearing that the one next is this one. That's what the one is. And that angle that I want in here, purple, is 228 minus 54. What I work out to? How much? 134. 74. Right? So 228 minus 54. What did I get? 174? 174 will be done. Last question. You don't get me upset, so upset. This question says, in the diagram below, O is the origin right here. And OE is 2 times EF. OE is 2EF. So okay, I make a note of that, right? So that this is 2 parts to 1 part, right? Because of 2 EF in it. See that? So this point divide the line in the ratio 2 to 1 right now. That's what happens. Divide the ratio 2 to 1. This line is twice as long as that. So that's 2 parts to 1 part. So it's 2/3 of the whole line. 2/3 of the whole line. And it said M is the midpoint of this side. So this line, this M divides the side half and half. All right. It says OG is C. Let's put it down. What this vector is C. So right here, so it's C. And then the whole of this vector up here, so it's D. So the whole of this vector is D is 2/3 of it, and this is 1/3 of it. So I'm not going to put them on from now. So this becomes 2/3 of the D. And this little piece is 1/3 of the D. 1/3 of the D, because it's 1/3 of the whole thing. 1/3 of the D. But that's not that. You have to be able to break up a diagram like that. So you can see all the parts and see how you go around the diagram. That's what you want. Question says, find the vector FG. That's this vector down here. So FG easy because you have the two position vectors. The position vector of the G and the F. So it simply becomes OG minus OF. O times the last minus O times the first. So OG is C minus the OF is D. That's it. So you know this vector along this side, right? That's FG. Next part I want is EG. Same thing again. You have the vector O to G. You have the vector O to up to E. You have the vector to E and the vector to G. So no problem. So I'm going to use O times the last minus O times the first again. That's OG minus OE. Once you know the portion vector, you use it. The OG is C minus the OE is 2/3 D. 2/3 D. All right. That's it. Let's go at once. OM. OM. Sit here. You know how to go along that line. You just work it out. You just work out EG. So you can travel along this line now from E to G. So we can use half of this vector to go from E to M. So look at it there. To go from O to M, we're going to go O to E first, and then E to M. Where the EM is half of the OG, the EG, right? Good? Let's write it up here, sir. To go from O to M, we're going to go O to E first, and then we're going to go E to M. O to E, E to M. But the E to M is half of the EG that we just found. So it becomes O to E, and then half of the EG. That's what EM is. Half of the EG. And the EG is this thing. We need half of that. So that's the calculation we do. So copy this and put it on here. So I just move it down. I'll do it on the screen so you can see it. Right? And so the OE remember now is 2/3 D. So this is 2/3 D plus half of EG is now half of this. So it becomes half of the C, that's half C, and then half of this, half of 2/3 is 1/3. So you're gonna get minus 1/3 B. I need to consolidate these values. So it really becomes half of C, and then 2 minus 1 is 1 over 3. So it becomes 1/3 B. That's the answer for O. Half C plus 1/3 D. What else I want? Now come to matrices. It says matrices P, Q, and R are given as those, right? Where A, B, and C are constants. Given that P plus Q is equal to R, find the value of A, B, and C. So if P plus Q is equal to R, it means that this plus this is equal to this, don't it? Again, this plus this is equal to that, right? So we can set that up. So we can set 3 plus -1 is equal to C. 3 and -1 is 2. So you can say, therefore, the C equals 2. That's 1, 2. The next one, this plus this is equal to that. So it's A plus -4 is equal to -4. So it means that A equals 0. -4 and -4 cancel each other, right? The next one, this plus this is equal to that. So it's going to be -9 plus B is equal to -3. So K1 and 9 also add it, you get the B equals 9 minus 3. So the B equals 6. So those are the answers. A is 0, B is 6, C is 2. Is correct. Next one. So solid period of time at equation is the matrices method, matrix method. If I write the matrix equation first, so it's going to become a 2 by 2 matrix times the column matrix XY equal the column matrix with these values 44, 10. And the values coming here are the coefficients. So you have 5 and negative 2 up here, so you have 2 and 3 down here, so you want to find the x, you're going to put the inverse of this in front here. You want to find xy. So you're going to get xy equals the inverse of that matrix. 5 minus 2, 2, 3. Put the minus 1 on it. That's the inverse of it I want. Times 44, 10. So we need to work out the inverse of this matrix right here. No work out it. 5 minus 2, 2, 3. So you take this inverse and this matrix and bring the inverse in front of you. So I have to work out the inverse. That's why I have the minus 1 up here. Good? Good. So xy comes equal to 1 over the determinant. The determinant. This product is 5 times 3 is 15 minus this product, which is 2 times minus 2 is negative 4. That becomes a plus. Minus minus becomes a plus. So this under here is really 19. Multiply that by the adjoint matrix. The adjoint is to interchange these 2 on the first diagonal. Interchange them. So 3 goes here, 5 goes here. Leave these 2 where they are, change the sign. Change the sign of this negative 2 to a positive 2. Change the sign of this 2 to a negative 2. This is the inverse, right? And still multiplying it by the 44, 10. 44, 10. They tend to work out the multiplication of those first before you divide by the 19. I remember this smaller, because I don't give a lot of space to work at all. And zoom. So it becomes equal to 1 over 19. And I'm going to multiply these 2 matrices now. So remember, I multiply the rows of the first matrix with the 1 column. So the first value up here is this row times this column. First element times first element, second element times second element. So it's 3 times 44 and 2 times 10. What is 3 times 44? That's 120 plus 6 plus 12, right? 132. So it's 132. 132 plus 20. That is 2 times 10 is 20. Then this value down here, this row times this column. So it's minus 2 times the 8, the 44, and 5 times the 10. All right, so it becomes the minus 2 times the 44 is negative 88, and 5 times the 10 is 50. So you see you get some nice values. You get multiples of the 19. It's xy equals this. So it becomes equal to 1 over 19 still times. So let's work out now. 152 works out to negative 38. 152 divided by 19 is how much? 8. And this is negative 2, right? Don't stop here, right? So the x equals this now. So don't stop at the matrix. You're gonna write now that the x equals 8 and y equals negative 2. Y equals negative 2. Those are your answers. And I want to hear how much you got. End of this test. Let me hear how much I got. People online, I want to know how much I got.
$70.
Huh?
70.
Not hearing you. What you say?
70, sir.
70?
Yes,
The
sir.
pass mark was 80. You must say it's far short. If you read all the questions you got wrong.
Yes, sir.
We're doing some more papers this week. I'm trying to get the 80 by the week is over. I have 2 more chances to get 80 this week. Then the pass mark moving up again next week. Pass mark for this week is 80. How much you get? Why don't we the paper? It's the same thing we do every week. I always have some excuse for some foolishness. Hey, you know, defeating yourself and not beating yourself and you in particular always have some stupid excuse for something. Well, all right then. We're not sure it tomorrow then. Let's see about that one. All right. Huh? 78? All right, not bad. So, so do what question may get right. And you never do it. I'm going to do it too. How about you? You do that paper here? Who else do the paper? What you get? Good. Still do what the 50. Still do what question may get. Have I ended now? Yo, come here, man. You're going.